So
Look at those.
this is basically Einstein is wrong again, and it's looking at it from the history.
Wrong. Yeah.
Okay. Now there have been numerous revisions to relativity, and I will only give a rough outline. For those criticising relativity, there has been a problem that the mainstream has not often made it clear about these revisions. So if you're criticising it, you've got a problem with the revision. Right, so my lecture is going to be in 3 parts. It's the history of relativity after Einstein, the history of relativity before Einstein, and then I'm going to do a bit of maths, which I don't understand. Okay. Part 1. Einstein is usually portrayed as discovering relativity, although Poincaré, Lorentz and others were involved. There is a tendency to ignore this. And what's happened, there is a renaissance of relativity, which is basically a rewrite of Einstein's relativity. So this man, Oppenheimer, is the father of the atom bomb. So he's a top scientist. And Oppenheimer considered Einstein an idiot, which is quite a shock, really. Quote, here's Einstein's early papers are paralysingly useful, but they are thoroughly corruptive errors. Alright, so others have considered Einstein an idiot, but often their reputation was damaged by doing that. But so Oppenheimer was allowed to consider Einstein an idiot, and you look at what Einstein says, it's pretty full of mistakes. Right. Now, Wheeler, this is another top scientist, John Wheeler, and what he did was he resurrected Einstein's relativity.
Also misinterpreted.
That's the other way of looking at it. Yes.
Misinterpret.
Revision.
Tomorrow I'll talk about it.
Revision.
Not revision.
Yeah.
Misinterpret. I can say is
Charles Milsner says, quote, what I think is the most important contribution John Wheeler made was to put genuine relativity out of the discard pile and get a large number of people actually involved working on it. So that's where it's quoted from. So basically, so basically, Einstein was considered an idiot by a lot of top scientists like Oppenheimer, and they threw it away. But John Wheeler brought it back again. So Einstein's relativity was taken to the landfill, then Wheeler brought it back. What then followed was a renaissance of relativity, and it's written in their books, this is renaissance. And the problems with relativity were supposedly sorted out. But looking at it, there were still major problems, that's my opinion. And we had the confusion of what Einstein said and what these later people supposedly changed. Right. So it leads to books like this. Hans Oppenheimer considers himself an expert on Einstein's general relativity and so forth, and he's bringing out books like trying to point out mistakes that Einstein made with relativity. So it makes everything confusing. There's a Wheeler school of relativity, and they're not clear what they have changed and why they have changed it.
I know.
Yeah. You know already. Sheldrake. Right.
Sheldrake.
This is Professor Sheldrake. He's a biologist, and he's got a lot of maverick ideas, and like from the Cambridge, Oxford area. Right. He did a lecture, and it was banned. You can see it on this.
Yeah.
You can see it on the internet. at that address, what happens is they do science talks called TED Talks, special ones, where experts are supposed to give a talk, and he managed to do one and he got banned. He says a lot of interesting things, but the thing that I want to pick on, that experimental physicists admitted to him they were able to measure the speed of light as being constant, and so defined it as constant. And I think that's one of the reasons why they banned the lecture. Right, the speed of light constancy postulate is, to me, is not really clear what Einstein meant by the speed of light being constant when he said it in 1905. I read him and I tried to make sense of it. Nowhere. Roughly, it can be taken to probably mean that all inertial observers measure the same value of speed of light in vacuum free of the influence of fields. However, moving on, the speed of light defined as constant is a different theory to the speed of light being discovered constant, independent of it being defined constant. So you've got two theories here. If Einstein said the speed of light is constant, go out and measure it on an experiment, fine. If they measure it in an experiment that's constant, and it's proven his theory. But if his theory is, I'm going to define the speed of light as constant, that's a completely different theory.
Yeah.
There's two theories. Two theories.
I don't understand what that proves. Say again.
There's two theories of relativity here.
Yeah.
At least two theories.
What?
You could look and you find there's more than two theories.
Yeah, more than
So, what theory did Einstein mean? It seems that this renaissance of relativity has changed theory as to what light speed constant means. They have now taken it to mean defined as constant. So I'm going to pick that issue up and on. Right. Now, in part two, I've dealt with the history after Einstein, complete mess, roughly. Relativity before Einstein. Of course, relativity was around before Einstein, and we can go back to Galileo. One of the great findings of scientists is that the laws of motion are the same in frames of reference that move at constant velocity with respect to each other, and this is called the principle of relativity, and I'm quoting it from there. So that sounds alright. That's from Galileo. What Galileo did, he had one of his friends stand on the top of the mast of a fast-moving ship and drop a ball. So you drop a ball, the ship moves forward, and the ball traces out that path as it's moving. So you've got the velocity forward and the velocity down. So from this frame, it looks like the ball's falling straight down. But from the person on the shore, the ball's tracing out that path. Right. So this is the explanation of what I just told you. If you want to read it quickly before it buzz on. Now, a lot happened in relativity between Galileo and Einstein, and most of it gets missed out. You go to university, do your physics, they jump from Galileo to Einstein, miss out everything else, and they miss out telling you Wheeler's revision. In the 18th century, a lot of physics was written in Latin, and I'm now translating it. It has been mostly ignored, and top man at the time was a Father Boscovich, and he was looking at relativity, and they've never translated it. Well, most of it they haven't translated. This is Boscovich, Catholic priest, also a scientist. He was talking about quantum physics because quantum is a Latin word. he had a theory unifying quantum and relativity. Latin word quantum, relativity from Galileo, and it's what we would nowadays call a unified field theory. But I've got to emphasise, this is an 18th century unified field theory. It's an old one. It's done what you can't do after Einstein. Right. So we go back to this guy again, Wheeler, and his school of relativity. According to that school, Boscovich's theory is a unified field theory. However, they're ignoring it because it is an 18th century unified field theory, and they were looking for a more modern unified field theory. Reason they look for a new unified field theory is because of what Einstein did. And of course, taking into account, they've also revised what Einstein was talking about, or seemed to have done. And there's a sort of like admission that Einstein made lots of mistakes. So if we undo the mess they made after 1905, jump back to when things were okay, 18th century, we've got a unified field theory.
I don't understand how he could unify electromagnetism with gravity, because there wasn't any electromagnetism in the 18th century.
Voltaire is working from Boscovich's theory.
There's something else.
What was he unifying?
Voltaire is working.
Quantum and cosmos.
So, if you accept that, there was a unified field theory, 18th century. After Newton, they looked at what Newton was saying, and they tried to come up with a coherent theory to make sense of what he was talking about. And I've got the book. Anybody who wants to look at it, it's from.
Can you put it here, face it?
So it's from my friend over in Serbia. He's a professor of chemistry, and they know about Boscovich back there, over there. And his name is Professor Dragoslav Stokovic. I've translated the book with his official permission, of course, and he explains how quantum physics came to Boscovich's theory. Boscovich gave a force curve, and from that force curve, Niels Bohr, Heisenberg, and everyone else worked out quantum theory. So it's quantum theory with all the mistakes they made afterwards, but without Einstein's relativity, Boscovich's theory. So all I have to do is translate from the relevant languages it's in. Okay? So next I'm on to some maths, part 3. I'm pointing out there are too many problems with Einstein's relativity. So I only deal with one of those issues, because the whole thing's a mess. It's a total mess. I'm then going to derive the time dilation. I will present the usual derivation of time dilation, and then I will look at it again. Right. So this is quoted from that side, and this is the usual explanation of time dilation. They consider light going between two mirrors, going up and down, and then if those mirrors move, then from the person over there observing it, that light is not going in a straight line anymore, it's going at an angle. So it's going to come up, hit the mirror's going to move on a bit, and it's going to bounce down like that. Person stationary with respect to it is up and down. Person looking at the moving mirror sees a triangle. So they then plug in the maths for all this. They sort of like call this distance L. Say the mirror is moving at velocity v, constant velocity, and it takes time to do it. So the distance is vt. Same on the other side. You've got a triangle, it's a Pythagorean triangle. This gives an explanation of what I just told you. A clock is made by sending a pulse of light towards a mirror, at a distance L and back to a receiver. Some notation. T is time for the light to reach the mirror in the lab for a clock at rest in rocket 1. T dash is time for light to reach the mirror in rocket 1 in its own rest frame. L equals distance to mirror. So the times and distances are related as follows. L equals C prime T. And then by Pythagorean theory, you get that. Where you get L squared plus V squared times T squared equals C squared. I missed out the dash, I think. The dash should be in there. Yeah, I've got the dash in it this time. So this is the equation they use. And that's from Pythagorean theory. C squared, T prime squared equals C squared times T squared minus V squared times T squared. And from that, they rearrange it and they find T prime is equal to that. And that's what they call then the time dilation equation. But I want to look at what is a Pythagorean triangle again. This is the triangle. The hypotenuse is CT. The horizontal distance is VT. Is it? No, the horizontal, that one. That distance is VT. So the vertical by Pythagoras is C squared minus V squared all times T squared and the square root of that. And so why have they made that equal to CT prime? They made that equal to CT prime, so why do they do that? That distance is CT, that distance is VT, and that distance is the speed times T. If we were Newtonian physics, then it would be T equals T prime, and this speed would be called the speed of light, which would be that distance, the speed going up there. Speed of light C that way, speed of light that way, C prime. Velocity that way, V. Just multiply everything by T, and you've got distance. So why did they do that? So we have the general equation, which is that. Well, I've made it C prime, T prime equals the square root of C squared times V squared, and that's all times time T. Einsteinians say C prime equals C, and then they get time dilation. Well, they should really do it by Newtonian physics, where they have T prime equal T. That one should be the same as there. Then that is that. Newtonian physics says do that. Of course, the way that the Einstein followers talk with their T and T prime being different, they go on to say things about the effect of space and time. So then having C equals C prime then gives them space-time effects. We call now Sheldrake's band lecture. They only have light speed defined as constant. So they've only done that by definition. So we have that as a definition. But why do that? In Newtonian physics, they should not be doing that. So let's look at the logic. My conclusion the other day, is similar to what was said yesterday. There is a thing called proof by contradiction. And the method is make an assumption, look at the consequences of that assumption. If that leads to a contradiction, then it disproves the assumption. So let's try to apply this to what Einstein does. He starts by assuming light speed is constant. I'll remind you that relativity principle is part of Newtonian physics. So in his 1905 paper, when he starts into assumptions, the relativity principle is already part of Newtonian physics. The only thing that he seems to be doing, which is new, is make the light speed constant, and that's an assumption. It is not clear what he means by that, but in the maths it seems to be saying c equals c prime, and that gives him time dilation. Now proof by contradiction to this is adding the assumption of light speed constancy to Newtonian physics. He gets time dilation from this. In Newtonian physics, there is no time dilation. Therefore, by proof of contradiction, the assumption of light speed constancy is false. But he does not follow logic, and he's got everybody else to follow the same way of doing things. Instead, Einstein assumes light speed constant, then adds to this, he assumes that there is time dilation.
As a fact.
He then keeps adding more assumptions. He assumes length contraction. He assumes change to momentum, which he calls relativistic momentum. He just keeps adding more and more assumptions. That's not logic.
No, I think you're wrong.
Einstein just keeps adding more and more assumptions.
No, you do. Let him finish.
Oh, come on. Let him finish his presentation.
And the more assumptions that he adds, the more there is the change from Newtonian physics. There is no justification for each of these changes. He just makes the change. He assumes light speed constancy, that leads him to time dilation, so he assumes time dilation, and he doesn't say why he's making all these assumptions. He violates logic. Right, Glenn Baxter.
Yeah, I know.
I was hoping to get Glenn Baxter here,
I know.
because I like arguing with him.
I know, it's kind of fun.
Now, he calls C equals C prime as a mathematical state. Right? I look at it, and they now seem to have defined C equals C prime as revealed by the band lecture. So they don't mind doing the equivalent of defining 1 equals 2. And so I have a difficulty with saying that C equals C prime is a mathematical state. Saying C equals C prime is equivalent to saying 1 equals 2. If you do maths where everybody agrees that 1 does not equal 2, and in the pages of some mathematical calculation you have 1 equal to 2 hidden there somewhere, then we could all agree that that was a math mistake. But with Einstein, it seems that 1 equals 2 is allowed. He's allowing it. And he has maths based on 1 equals 2. So calling it a math mistake is more difficult to my mind. It's more like what he did was abandon reason. Well, the way I look at it is, the basic equation is that by Newtonian physics, we would look at our equation and see T prime equals T, and then we get C prime is equal to that. But Einstein and his followers implicitly or explicitly did not do that. So the question I would ask them is, why the change? Why did you make the change? They would say they are going by experiment, to which I would counter them and say, I refer you to the band lecture of rate, which points out they are going by a definition equivalent to saying 1 equals 2. So my conclusions are, we have been really profoundly messed up by Einstein. There are many mistakes in Einstein's works, and even the Einstein supporters kind of accept that as well, to some extent. And I refer you to other distance work like Harry Ricker, Nick Percival, Stephen Travers, Hartford, Pym, etc. Einstein being portrayed as a hero has made it difficult to correct those mistakes, because those who do try to correct those mistakes risk being speared by the hero worshippers. So the establishment has been persecuting dissidents like this for a long time. There's many examples now of modern day Galileos being persecuted by the establishment. This is one of my favourite ones. The establishment has become more skilled in persecuting Galileo types. In Galileo's day, the establishment responded by the threat, by threatening him. And that felt as an adequate method. So they have become more skilled since then at suppressing dissent. This is human behaviour they have learned. The people who like suppressing dissent have learned how to suppress dissent. And it's namely by rewarding you with prizes, e.g. the Nobel Prize, and funding you for research you don't dissent. So they worked out from the carrot and stick approach, where they found that making the carrot bigger was better at controlling dissent than using the stick. They used the stick on Galileo, it didn't work, so they've now used the carrot. And so that's my conclusions. If you then decide, well, Einstein did it a bit wrong, let's look.
You're wrong.
Sorry. So if we decide he did it a bit
Yeah,
wrong.
I explain to you why you're wrong, but
Okay.
now it's your lecture.
Later, yeah.
Later, after the beer. You have to buy a beer first.
So if
So
you
you can
decide,
explain.
if you decide Einstein's wrong, look back earlier.
Einstein has many mistakes, but not include those you mentioned.
Well, it's a revision.
No.
It might not be a mistake by him, but it's a revision to what he did. Okay.
Not Einstein.
So if you look back in history,
Yes.
there's a unified field theory already.
Okay.
Einstein couldn't find one. If you decide he's wrong, look back, and there is one.
1840.
Yeah.